Hi everybody, today we're going to discuss triangles. So the next unit is all about triangles. And we need to clarify a few things before we move much further. First of all, we need to clarify what is a triangle. Now I know that seems like a pretty simple question and you probably know what it is, but it's always a good idea in mathematics in particular to start with a definition so we know exactly what we're working with. A triangle is a three-sided polygon. Now, we haven't talked about the word polygon either, so I need to break that down a bit. The best way to think about a triangle is a figure that's made up of three line segments joined at three vertices with three angles. And that's it. It's exactly what you think of. We don't have to belabor that point too much, but it is important to talk about it. The second thing I want to talk about here as we start talking about properties of figures such as triangles is that one really super important thing in geometry is we can't assume anything. That means that we have to be able to show that something is true before we can make an assumption about it. Just because we think it looks like an angle is 90 degrees, unless we know for sure that it is, we can't make that assumption. So that's just a general rule we want to be sure that we're keeping in mind as we go. If two sides look like they're the same length, that's all we know. We don't know that they are the same length until we're able to show that that is true. Okay, so with that out of the way, let's start talking about the first fact about triangles. Many of you are probably familiar with this already, but let's dive right into it. In class, we should have created triangles. A three-sided figure here, and we should have, ideally at this point, have created angles that measure them as well. So I have my triangle ABC, and I'm going to make sure I have my move cursor selected so that I can move around this triangle. Now, I'm changing the length of the sides. I'm changing the orientation of the triangle. Okay? And as I do all that, you can see numbers on the left. The segments here are changing in size. And the angles that are drawn in the figure are also changing in measurement as we go. So what I'd like us to do here is I want to investigate the first fact about triangles, and I want to investigate the angle measure of the triangles. So take a moment here, pause the video, and take a look at the triangle on your page and tell me if you see any relationship between the three angles. Now, hopefully when you're looking for relationships, you're asking questions about, are they equal? What do they add to? What's the difference between them? And hopefully, if you take a look at your triangle, give a shot and try adding up all three measurements. You can use a calculator. You can go by hand. It doesn't much matter, but I'd like you to take a look and see what the sum of those three angles are and see if we can find some kind of truism about the sum of interior angles of a triangle. I've pulled up here my calculator, and I'm going to go ahead and add up the three angles in my calculator. So I have a 44.21, I have an 82.78, and I have a 53.01. I add them together, and I get exactly 180 degrees. Add yours up, tell me what you get. Ideally, you're going to get 180 degrees as well. The only difference may arise because of rounding in the machine. So if you ended up with 179.9 or something very close to that, 180.1, that's okay. That's only due to a round-off error in the machine. So we notice that no matter how I change the triangle, that is, no matter how big the triangle is, no matter if there are obtuse angles or acute angles, if I add up the three angles in a triangle, they always add to 180 degrees. And this is the first fact of triangles that we're going to play with over the next few days. It's a really important idea, and we want to make sure we are comfortable with this concept. It's one of the things that makes something a triangle if the three angles add up to 180 degrees. Let's see why this is true. This is where I want you to pull up the second picture that we made in class. What I have here are two lines that are parallel. This is called line F, and this is called line G. Those are parallel to each other, and what I've created from that is one transversal, this is line H, and a second transversal, this is line I. And you'll notice that these two transversals meet at one point. So another way to think about this is it's a triangle A, B, C, where I've created a line parallel to the sides of one of the sides of the triangle. Okay, but the triangle that I'm interested in evaluating here is triangle ABC. So let's take a look and see what we can find out about this triangle. Now, the first fact I want to look at here is that I have three angles, this angle right here, this angle here, and this angle here. And those three angles are going to add to 180 degrees. So I've actually moved a picture of this into a drawing program so I can mark up the angles. What I have here is this angle, and this angle, which all add up to 180 degrees because they form a straight line together. Okay? These three angles are going to add to 180 no matter what they are. And now what I want us to do is take a look at some of the relationships using parallel lines. So if I take a look at this angle here, this angle right here, okay, and I compare that to the alternate interior angle on the other side of this transversal, notice that this angle here and this angle here must be congruent because they are alternate interior angles with respect to these parallel lines and this transversal. Now I'm going to take a look at the angle down here. I'm going to look at this angle here, put two hatch marks, and its alternate interior angle right there. So you notice that because we have parallel lines and a transversal, this angle and this angle are congruent because they are alternate interior angles. So what do I have? I know that this angle, and this angle all add to 180 because I can see that they physically form a straight angle or a straight line. So the angle without the hatch mark, the angle with the hatch mark, and the angle with two hatch marks add to 180 degrees. But because of alternate interior angles, I can see that this angle and this angle are congruent. This angle and this angle are congruent. So these three angles add to 180, meaning this angle, and this angle must add to 180 degrees. These are the three angles on the interior of this triangle. So this picture is what justifies to us the fact that the three angles on the interior of a triangle must always add to 180 degrees. Now you might say, well, Mr. Null, you built that from parallel lines. It's true that I did that, but I can always build the same picture from any triangle. Let me go back to the first animation that we looked at. This is just a triangle that I built. And now my argument to you is that I can create the same picture from any triangle that you choose. So I can, as long as I'm allowed to make a parallel line, I can do it. Simply by doing that, creating a parallel line to one of the sides of the triangle, I've done exactly that. Notice now I have my alternate interior angles here and here, my alternate interior angles here and here. This is the same pictures we had before, and I got it simply by drawing a parallel line, which we're going to assume we can always do on any triangle you choose. Okay, so the big takeaway from today was that the interior angles of a triangle must always add to 180 degrees. Thanks for watching.